Let's work on question 5 in this video. So we have the following linear programming problem. Now we have to maximize x plus y due to the following constraints. Now in part A, we want to show whether this problem has a unique solution or no solution. Now, how do we do that? To understand how we do it, we're going to do it on a graph. And the idea is that we have a relationship between x and y, meaning we have an actual line which can take a maximum value on a certain interval. We want to first define that interval to see what that is, what is the area of possible solutions on the graph, and then we want to see whether we can achieve a maximum point. So let's start one by one. First of all, let's define our constraints. What does it mean to have x minus 4y less than or equal to 4? Well, let's solve it over here. This is going to be a line, x minus 4y less than or equal to 4. Let's take the y value on the other side, so we get x, bring 4 to the left side, minus 4 less than or equal to 4y. Now if we divide both sides by 4, we would get 1 over 4 x minus 1 less than or equal to y, or let's write it in a different way, that minus 1 plus 1 over 4x is less than or equal to y. Okay, first of all, let's understand that this is a line, right? The actual line is minus 1 plus 1 over 4x. But for our question, the values can be at least the values on that line or greater than them. Let's do it and we'll see what it means. So, first of all, we need the intercept. We need the intercept of minus 1. We put it on the y-axis as the intercept of minus 1. We need the intercept for x, which is going to be 4. Because 4 times 1 over 4 is going to be 1. 1 minus 1 is going to give us 0. So it's going to intersect it at the value of y equals to 0. That's what we want. X-intercept is 4. Let's draw the line over here. So we draw the line over here like that. Yeah. This is the line of minus 1 plus 1 over 4x. Now what do we need? We have to keep in mind something. We have to keep in mind that we need values for x and y that are greater than 0. So meaning above the x-axis, right? Above the x-axis and to the right of the y-axis. We'll see how that works out. Don't get confused about the language. And we also need to know that the values for our solution must be at least, that's what this equal sign shows us, it must be at least the values on this white line or greater than that. So let's see what would be that range. Yeah, I think green will be a good color here. Now, x must be greater than 0. So values for x greater than 0, it means everything to the right of x. So that's going to be one range. And y has to be greater than 0, meaning that the possible values must be greater than the x-axis. So it has to go up. This is going to be that range that we're interested in, defined by this line, right? Up to the white line, right? The line is the boundary. That is the limit. What did we say? Well, we said that the values must be at least on this white line, at least, or greater. Why? Why is the solution of this inequality? So the solution must be at least the y values on this white line, right? Defined by this interval like that, defined by this interval, or greater than. So that's why we go with the y values up, because these y values above the white line are literally greater than what is happening on that line. Hope this all makes sense. Now, with that said, we do it for one more. We do it for one more interval. So we do it for the second interval, which was this one. The second constraint, better said, not interval. Minus x plus y must be less than or equal to 2. Let's solve it. Let's solve it over here, just like we did now. Let me zoom out to get more space, because it feels tense now. Minus x plus y must be less than or equal to 2. Let's keep y on one side and take the x on the other side. So we would have y less than or equal to 2 plus x. We bring this to the other side. So 2 plus x. Yeah, I said 2 plus x. 2 plus x. Okay. Now we have a new line. Let's draw it with a different color. Something like this. Yes, this will be this one. Yes. A new line with the intercept of 2 and a positive slope of 1. So what does that mean? Well, let's go over here and draw it. The intercept on the y-axis is going to be 2, somewhere over here, and the slope is positive 1. So the slope will have a 45-degree angle, something like that. Okay, this is the new line that we're having, y equals to 2 plus x. Now what matters to us? It matters that we are bounded by the fact that x is greater than 0, y is greater than 0. So let's let's color this region as well with a different color to make the distinction, meaning we're interested in the range again to the right for positive x values, and here upwards, meaning that we're interested in positive y values. But the values of this solution, of this, the values for y must be less than or equal to that line. So whatever values we get on this line, I'm pointing right now, whatever values we get on this line, these are the maximum values that we can get or smaller than them, meaning that the y values, the actual solutions, must be less than that as well. So these are possible solutions. So this area bounded by this interval, which go below the red line, is the set of possible solution. And since we're working with a system of inequalities, right, this is a system, remember, they all must satisfy together. So the area of possible solutions is going to be this entire thing, this shaded area over here, you see, this range over here. And we can see this range has no limit because the lines are expanding. The lines go there and this one goes there. So this area keeps expanding. Now, with that said, can we get a value for x plus y that's gonna be a maximum point? Well, let's prove it with an example that we can't, because let's assume that the value for x plus y would be equal to 5, for instance. Well, x plus y is equal to 5 is just a line. That's y equals to 5 minus x, meaning that the intercept, let me change colors to show it. Hope this was already this one. The intercept would be 5. The intercept would be 5, so somewhere over here, and the slope would be -1, meaning that the x-intercept would be 5 as well. So on this line is showing us a possible solution. For instance, we assume that. Can we make this a larger number? Well, we can. Look, if we make x plus y not 5, but we make it 8. Well, in that case, the new line is going to be y equals to 8 minus x. So we're just going to shift the line to the right. We're going to go from here, 8 minus x. So it's going to look something like that. So what did we do? We shifted the line. But we can still do that. We can still do that. We can still do that infinitely many times because we are not bounded. We are not limited by these two lines. There is no limitation over here, meaning that we cannot find an optimal solution. We cannot find a maximum solution. Yeah, that's it. We cannot find a maximum solution. Hope this makes sense. In the next video, we will go to part B.